Alright, so it's time to bust out some of the stuff I ordered a couple months ago. So what is this? This is 1.8 kilovolt. I don't remember what the deal was on this stuff. It was really, really cheap. You had Chinese writing on it. And put that one over there. This was 30 feet of 10 gauge. The problem with this, it doesn't have connectors on both ends. And then I got this one here. This was Kim Bluth 10 gauge solar RV boat wire, new, made in the USA. I don't know how long it is, but I think it's 40. Look at that. That looks actually nice. You can kind of feel the insulation on some of them. They're a little bit different. But what I do is I wait for this kind of stuff to go on sale on Amazon, and I order it when it becomes less than $1 a foot for a pair. You could definitely get it for less than $1 a foot, but there's like, if you want 40 feet of wire, you don't want to pay 40 bucks. And so this stuff here is good to go for me. I can go out here, I can extend my panels like I need to do with that. I can do it with the other ones too, and I just have to put connectors on the other ends. This idea with this was like it was meant for an RV. And you have a bare end right here that you would run into your charge controller or inverter. And, you know, this would go out to your panels. It's just a 30-foot feed, you know. So for me, I had to have a couple of extensions, because what I'm doing is I'm laying a couple of them on the ground right here, and then they're going to be in parallel. So I'll lay these down. They're on the other system. So the wires go to here. This one's actually tied in with those. So what I need to do is I need to either reach these ones back here, which will do really, really good. And it'd be great if I could actually like just fit 4 back here. But I still need to reach them. So I could do it either way. And then I have an oddball one. So I either need another one or I need to remove one. So I can do 4 panels, which would be 20 amps almost under max conditions. That's the most you want to run through this anyways. So otherwise you'd do multiple feed lines. That's why I don't really care for the 24 volt system, because it's limited to like under 115 volts. So you can only really put 2, maybe 3 panels in series. Whereas like with my other one, I've got 8 of them in series. And that makes the voltage really high and the current really low. And then the wire is perfectly fine. But if you wanted to run, so like something stupid like 60 amps through this, I mean, you would need double the wire. So, you know, instead of 10 gauge wire, I don't know what would be, but probably 4, maybe 5. There's a chart that gives you the breakdown of all that, but 10 gauge wire can handle 30 amps, but it's not good. So we got to decide if I could just probably put those back there, or I could just put these here, you know. So that's the thing. It's like, well, I keep the feed short. See, it like ends over here. It also means that I'm going to have to run the dirty green inverter. But if I've only got 4 panels, I can pull out another EP-Ever charge controller. I just have to make up another set of battery terminals, which I don't really want to do. So I think what we'll do is possibly just put them all right here. I can put my branch connectors here. I don't have to worry about reaching all the way to the other side. The problem with over here, even though it picks up pretty good sunlight, is at a certain point in the day, you start to get a shadow. See, the other panel would have to be so damn close to right here that you would have a shadow on part of it. But it's definitely an idea. I mean, I can just swap the feed line, basically. I don't know why I'm calling it the feed line, but that's what it is. It's feeding everything. I could swap that and make it to reach them and have them all over there. I'd rather not have these laying on the ground here. So I think that's what I'm going to do. Because the problem with them on the ground here is they get covered in dirt and crap. So we'll probably just move these then and look and see what does it look like. How are they going to be? And so just these two right here are making 51 watts. In fact, a little bit less, but we have 69 volts. If it'll focus, at 42 watts. We've got a storm coming. But anyway, yeah. So that's what it does at this power level. Basically, I'm charging these batteries here. They're actually almost full, so there's not going to be like a huge draw on this thing. I could flip it on to put a load on it, and let me see here. I gotta wait for it to kick on. So I've got a fan down here to put a load on it. What a lot of people don't realize is that these oh, the thing's got to get cleaned. These things actually draw quite a bit of power when they're idle. Like if you have the inverter on, for sure, and even if you're not using anything. So I would say probably 150 watts they probably draw all the time. And that actually ends up being quite a bit at the end of the day. That's what's so great about this thing, is it draws like 30 or 40 watts. And, you know, just more efficient. But the goal here is to over panel and forget about efficiency. We want redundancy, we want, you know, all that good stuff. So right now I'm making, it shows you the MPPT process, by the way. You get 62 volts at 1.1 amps, and it converts it to 28 volts at 2.5 amps. It buck boosts the current and voltage. And that's what's so good about using the newer type of charge controllers. Because instead of having to waste that high voltage by pulsating it on and off to chop it down to 28, it's able to do it like this. So right now our batteries are basically full, so we're not really going to be able to hook up the rest of the panels and tell what the hell is going on. If I really want to, I could go in the house and kick on the big air conditioner. But we are probably not going to see enough sun to recover very quickly, and I just always like to have these topped off. They're not quite balanced right now, but that's okay. And you hear it go click. This thing does this all the damn time. So now it is just clicked off the solar and then clicked it back on. And that's why I do not like this inverter. I don't know if I have a bad one. I contacted him. Oh, that's normal. No, it's not normal. This thing shouldn't be clicking on and off. Like you physically hear it go click. So, and this one here is a joke to use as a charge controller because it's only 40 amps. But I totally could do that if I want to instead. This is, I think, 80 or 120 amp charge controller, but it's noisy. I think they're both really just about equally as bad. And so anyway, I wanted to hook up the rest of the stuff. I don't have enough load on this. Oh wow, look, it's putting out 176 664. You guys can't see it, but it's starting to ramp up. I'm gonna actually go and kick the air conditioner on. So this one here draws a lot. It's also like 10,000 BTU or something nuts. If I had 2 of those air conditioners, I could probably cool the entire house. So we're pulling 2.4 amps. We're up to 217 watts over here. And then down here, I've got another one, 11.5 amps. 22.6 amps on the buck boost. Also, sometimes when you put a load on it, it actually neutralizes and balances out the batteries a little better. And you see that they're closer, 13.8, 14. So I'm going to add the rest of the panels here, but the 2 panels are in poor sunlight at about 200 and plus watts. So that's just these 2 right here. So then we'll pull our wire out and go around the corner. Let's make sure we're not shaded yet. You see the shade is coming in. And that's that wall there. We actually have some shading right there, and that will drastically reduce it. Alright, so we're going to get these little bundles open here. I like to clip these where I can save them. I'll clip them. You know, sometimes I'll even take like a knife and pry them open, but it takes too long. Just come in here like that, and then you've got a good zip tie you can use for something else. Interesting how they decided to use black and white zip ties. They actually like put the black zip ties on that, like kind of interesting. Probably made in 2 different departments. Alright, so I'm just going to take these and roll them out. I like to twist them up together usually, like how this one is. So that's what I'm going to do. Alright, so I stuffed everything underneath here. Okay, the wires just going around the corner for right now. And then we're just running these 2. We see we have some shading right here. We probably want to scoot them over. Alright, so that's a little less shaded. I'm just going to see what it's doing. Okay, so I have a significant load on this thing. Oh, we're making 492 watts. So that's not too bad. A little more than 100 watts a panel. What do we get? This one here, you can read the watts. I actually prefer to read amps, not watts, but I mean, you know, whatever. So if we go into here, this thing doesn't have the correct date because I reset it again. It'll let me know that it's making 75 watts. So 2.8 amps. 1.2 basically in is 75 watts. And this one here, well, you guys aren't be able to see it, but it's making 22.5 amps. And it's got 6 panels. So there you go.